put yourself in the queue or something like that. In any case, we'll go ahead and get the chair administrivia out of the way. You should definitely by now know what the note well is. I recognize most of the faces in this room and know that you know what this means. For the few I don't know, I'm going to point out that if you have not read BCP 78 and 79 and you want to say something to the microphone, go read 78 and 79 first, because it might have implications on your IPR. I have already managed to procure a note taker and a Jabber scribe, so I'm going to go ahead and just throw the blue sheets out there. I'm only circulating one because I don't think it's going to fill all the way up. And as I mentioned, we have the one topic today. I don't expect it to take much more than half an hour, but we do have plenty of padding at the end in case it does. And this is going to be done by Dale from remote. And I will again ask if he can get in the queue, because we're pretty much done with this part of the presentation. And we're moving on to his work momentarily. Jonathan, is Dale in the... Okay, can you ping him for me? Do one real quick thing here before we get too deep. There we go.
Okay, now I think Dale is detected for the requested links. I think the presenter is not sending to you.
Okay.
So, as a Dale can unmute everyone. Okay, so. Gita says Dale can unmute everyone, so Dale, I guess if you
Dale, if you can hear me, you should have an unmute control that allows you to put yourself on the screen here.
Can you hear me?
Oh, there we go. Brilliant.
Okay. I found the unmute control. It's not actually labeled terribly well. I suspect that's what's going on is I have a separate interface because I'm connected using a special presenter URL.
Okay, so can you see the screen that we're showing right now? It should be your slide.
I do see the slides. Is my volume okay?
Yeah, it's perfect, yeah. Okay, start when you're ready.
Okay. This work is what is essentially happy eyeballs for SIP, supporting SIP well in dual stack deployments. It's a continuation of work that's been going on for quite some time. Next slide, please. There we are. Ole Johansson, Gonzalo Salguero, and Roman Spound are co-authors on the Internet Draft, which is the first half of this work. And a lot of what I'm presenting here is work that I've done jointly with them. Not a huge turnout. Okay, the problems that have to be solved is that the core SIP RFCs are written to support both IPv4 and IPv6, but unfortunately they don't handle dual stack deployments very well. RFC 6157 talks about IPv6 transition, but it doesn't solve the happy eyeballs problem. In fact, it simply states that it's a problem. And as discussed extensively on the list in the past, 3263 is not clear on the DNS procedures to be used in dual stack networks. And also, just reading the chat room there. And also there's a serious happy eyeballs like problem in SIP due to long transaction timeouts when there's no response. Next slide, please. Okay, the work that's been done so far is in draft IETF SIPCORE DNS dual stack, which is the title of this next slide. It addresses the narrow problems of DNS SRV record lookups of SIP servers in dual stack environments. It basically cleans up these procedures to be what everyone thinks they ought to be, but was not actually written as such. It addresses these two issues by requiring that both A and quadruple A records be looked up by dual stack devices, and then documents that, as a consequence of all of this, DNS SRV records can be used by a server. It indicates preference of address family to communicate with it. This draft is now working its way through the IESG. Next slide, please. This one is titled "The Next Increment of Work," which is basically what's needed to solve the fundamental happy eyeballs problem with SIP. We need to allow devices to change the target order that's prescribed by RFCs 3263 and 2782, so that it can give preferences to targets that are known to work correctly. We need to encourage UAs to either maintain flows or to probe targets before sending requests to them, so that it doesn't get stuck having to wait for a request to timeout. We need to reduce transaction timeouts, which right now default to 32 seconds, because if an invite request waits 32 seconds to time out, the user is going to hang up before the UA can fall back to the second target. And we need to make sure that current UDP approaches are still supported, because that's what people use in large-scale dual stack deployments. Now, a very preliminary version of this work is in a draft that I've composed, Draft Whirly SIPCORE Dual Stack. Actually, it's more a set of notes on what our thinking is about these various topics than a truly drafted internet draft. Next slide. Okay, in regard to changing the target order, which is the title of this slide, strictly changing the target order is allowed by RFC 3261 in section 8.1.2 as a local policy. But up until now, it seems that no one has ever actually talked about doing it. What we do need to do is to give implementers detailed guidance on how to reorder targets to get better effects. We need to emphasize that a UA can simultaneously initiate flows to multiple targets by various methods, depending on what the transport protocol is, but it has to have only one outstanding request at a time. Otherwise, we wind up with duplicate requests causing merge requests at the destination. And we need to have a consistency requirement that if a set of targets are accessible for a long time, the behavior of the UA in regard to the distribution of traffic among them must approximate over the long time what 3263 prescribes. In particular, cached information about non-reachability has to time out. Next slide, please. Okay, this is titled Flows, Probes, and Keep Alives. UAs should maintain some sort of current flow status with the targets of its home proxy, so it knows which targets are accessible and which are not. There's many different ways of doing this. SIP Outbound, RFC96-26, is the best known of these. An alternative is that the UA could probe the targets before sending requests to them. It can do this by various keep alive methods. One technique, which actually is fairly universal, is that it can send an options request with max forwards of 0 to the target. And if it gets a response back at all, it knows that the target's accessible. Next slide, please. Okay, this is titled Reduce Transaction Timeouts. Currently, timer B and timer F, which are the invite and non-invite transaction timeouts, are set to 64 times T1, T1 being the estimated round trip time. The default T1 is 500 milliseconds, which makes the default timer B and timer F 32 seconds. And this is actually much too long to be used for fallback in invite requests in practice. Unfortunately, reducing T1 is probably not a good idea because it affects many other timers throughout SIP as well. If we reduce timers B and F without reducing T1, that lowers the number of retransmissions, unless we change the retransmission schedule. And in any case, shorter timeouts are more vulnerable to intermittent connectivity. So there's actually a whole series of complicated issues here. and it's not clear where they balance out. Next slide, please. Okay, this is the first slide on large-scale dual stack deployment. The next block of work is a series of issues that show up in large-scale deployments and become intensified with dual stack deployments. Because of overhead concerns, dual stack usage has to support something resembling current UDP approaches. SIP Outbound is understood as the correct way of solving many of these problems, but it's not widely deployed. We need to make sure we have a good understanding of why, which, as I said, seems to be a perception that the overhead involved is excessive. We need to know why that is. And it's worth checking, should we define some sort of subset or revision of Outbound that reduces these overheads so that Outbound can be used effectively in very large deployments. Next slide, please. Okay, the second slide for large-scale deployment. There is a demand out there for a low overhead, low state signaling encryption system. What's needed is a way to protect signaling traffic from application level gateways, which want to rewrite requests and responses so as to handle NAT traversal and such things, but they often do it wrong, and it causes a great deal of trouble in practice. What we really want to do is to have SIP handle all these things inherently and then stop the ALGs from messing everything up. DTLS is similarly seen as having excessive state and overhead requirements. But it seems possible that we can come up with some sort of subset or variant of DTLS that piggybacks on the work we've already done, but avoids DTLS's difficulties. Next slide, please. A broader but in the long run important topic is recovery in unstable networks, which is the title of this slide. A big problem is there's instability in networks, particularly with mobile usage. You get changing connectivity as to which IP addresses the device is using, and even what address family it's using. You get intermittent network connectivity. One of the things that's necessary to make this work is some sort of good failure detection. You can detect failures through the failure of signaling keep alives. You can detect it through the absence of media, or really what's better, the absence of RTCP, since even when you're on hold, you still get RTCP. You also get status reports up from the networking layer. And the things that need to be done is some method of call recovery so the call doesn't get lost. And also we need, unfortunately, to do transaction recovery, which is a more difficult problem. Not so much for in-dialogue transactions, but for invites, which can last for a long time and are much more vulnerable to instability. And we have to make sure that we handle the interaction with session timers correctly. They seem to be quite popular in carrier-based networks. And we have to make sure that we have proper guidance that session timers work correctly in situations where we can recover from instabilities. Next slide, please.
So actually, Dale, this is Adam Roach, and I would be at the floor except for I'm advancing the slides. Quick question on why the recovery issues are considered part of happy eyeballs by the people who've been working on this.
I'm sorry, could you say the end of that sentence again?
I just wanted to know why the recovery in unstable networks is considered part of the happy eyeballs work by the team that you've been working with here. It doesn't seem that these problems are unique to dual stack deployments. Am I missing something?
Well, you're correct. It isn't unique to dual stack. Dual stack, there tends to be situations where you have multiple possible networks, you don't know which one's actually working at a given time. It's inseparable. Oops.
Dale, I'm not certain what changed, but your connection has apparently changed significantly where we can no longer hear you correctly. You may be in an unstable network and need to recover. Jonathan, can I have you suggest to him that he disconnect and reconnect? Okay. Ole, you seem to have an answer to my question, though. So if you want to take it to the microphone, that would probably be helpful while we wait.
Advanced. Ole Johansson, I think this is out of scope for the work on Happy Eyeballs. And I think if you switch to the previous slide, I think this also is not really in scope. I mean, I would like to focus on setting up a flow, and that's the whole focus. Now that we have the other draft in process, we need to discuss how to set up the flow. And the way I personally see it, and I think Gonzalo is with me, we need to take transport by transport and say, well, for connection-oriented flows, point to Happy Eyeballs, and you can set up your flow, and we're practically done. Then for connectionless protocols, meaning UDP, we need to figure out ways. Outbound could be one way to register and then keep that flow, because it's not call sensitive if you already registered. But we may need to have other ways, since there's a lot of hesitation about outbound out there.
So like specifically, you don't want to address as part of this effort right now. Let me give you a very specific non-address. Recovering a call that had been running over V6 by failing to V4. If Outbound does that for you, great, but you don't want to add that to Happy Eyeballs.
Well, as we discussed on SIPIT, an event I'm sure you know, Outbound doesn't cover any recovery of a call, and that's something I would like to work on at some point. Outbound focus on setting up the call, but we still need recovery and retargeting. I think that's good work, but not related to Happy Eyeballs. And it can come on IP to IP. I think Roman on the mailing list told us that even when you switch from 4G to 3G, you get a new IP address allocated in some networks. So it's not only dual stack, it's single stack, but changing network.
Okay, real quick before you start, Krister Roman is on the queue.
Krister Holmberg.
Krister, before you start, Roman is on the queue. Sorry.
Yes. As far as I can see, those are three unrelated problems we're looking at. One of which is setting up the initial flow, and that's probably what should fall in the Happy Eyeballs, and in particular, setting up the initial flow for the unreliable transports. There are two other problems. One of them is, again, low overhead encryption, and another one is basically closing whatever gaps we have in SIP outbound, one of which is recovery. And I think what we should do is we should concentrate on the setting up initial flow, at least in this draft, because this is probably the highest priority and the one which is kind of most closely in scope for this project. And the other two problems, again, they're interesting and they probably need to be addressed, but they're not necessarily something which should be solved all at once.
Okay.
Krister Holmberg, I'd like to know what the definition, I think I've asked this before and it's not clear to me yet what the definition of flow is. When someone talks about sending options with max forward 0, it seems to me, okay, this is a flow that goes to the next hop because you're testing the flow and that next hop is going to reject it. The outbound definition of a flow is something that goes from the UE to the registrar. But then again, at some point, I think someone talked about the flow goes to the register. You have the edge outbound proxies, but the flow end terminates at the register. But then again, I see this word target. So that to me seems, okay, this flow is something that goes end to end. So I'd really like to know what is the definition of flow in this case? Okay.
It's a good question.
The way, again, I see this problem is what you have is you have a client which has more than one network available. And that is not only limited to dual stack, it's limited to, for instance, having multiple local IPs. and you do some sort of DNS resolution, and you have multiple remote targets available for which you can connect to the register. So you have almost like an ICE-like set of origination addresses and destination addresses. And realistically, client needs to figure out which source and destination IPs to use to send the SIP message. And that's fundamentally the problem that we're trying to solve. So in this regard, I think this is essentially a flow that client stack needs to pick. And we need to have a mechanism on how to pick which flow to use for the next SIP message. And depending again on the scope, it's either the flow for the entire transaction or even the flow for each next SIP message in the transaction. Again, if the transaction is long, running for a long time, such as, like, for instance, initial invites. That's it.
Oh, thanks. Do we have Dale back?
Not yet. Dale seems to be attempting to rejoin. He's no longer in the room.
Ah, okay.
While we're waiting,
Krista Holmberg, one of the questions which were presented here is why people don't implement Outbound. And one of the reasons, I mean, one of the original reason for Outbound was that you have these different registration flows that goes through NATs, and if some NAT binding goes down or something happens, you can switch to another flow. But I think that doesn't happen, and it doesn't happen often enough to justify implementing Outbound. Each registration flow, at least if you come from the radio work, when you create a registration, even if you don't send on it, it's going to consume resources. No one's going to pay for those resources, right? Your customer are not going to pay for you setting up the resources that you need for 4 different registration flows. And again, in most cases, you're not going to need those. I mean, the NATs will be open there. Often they're hosted NATs, and they make sure that things work. So that's one of the reasons why people don't see the need for implementing Outbound. But that, and I'm not saying that's right or wrong. I'm just saying that's one reason.
So do you think that the V6 transition use case would be sufficiently compelling for people to reconsider that?
Well, from where I come from IMS, I don't think V4, V6 is an issue. As far as I know, they only use V6, so dual stack or V4. But I haven't heard any issues related to dual stack there. So.
Okay, thanks. Before you go, real quick, Paul's on the queue.
Hi. I was just thinking as the talk was going on here, if this is a problem that, I mean, connection reuse ended up being broken into 2 parts. One part was outbound, when it was connection reuse to the endpoint, and it was a different document between providers. Is that the case here? I mean, you know, for the happy eyeballs. I mean, in other words, do we have a problem between providers at all? And if not, I mean, was that clear?
Ole Johansson here. I don't see any difference in those 2 cases yet when I looked at this. I mean, it's just about finding a possible IP address to play with given one DNS name, right? And that applies to both cases. But in response to Krista, Outbound doesn't require you to set up all those flows. It requires an implementation to support at least 2 flows, but you can run it with 1 flow. And that really helps in this situation. But it adds a lot of complexity for the developers. I guess that's why people are not doing that.
Well, just kind of to address both of those things. First of all, in production deployments, when you deploy provider interconnect versus consumer to provider interconnect. For provider interconnects, the number of providers is relatively small. The transports are essentially known in advance. If you're switching from IPv4 to IPv6, you test it in advance and you know exactly when you're using it. So it's a much less of a problem where you need to dynamically determine which network you need to use to connect between two providers. On the client side, you essentially don't know what network client is coming from, so there's no good solution for what's deployed right now. So to deploy, again, clients distributed across multiple networks connecting to you without you knowing in advance which transport they're going to come in. So that's providers. The second thing is outbound and not implementing outbound. There are two parts to that problem. The first part is essentially outbound over UDP. And one of the reasons why outbound over UDP was not implemented as much was because host-based NAT traversal for UDP worked fairly well for a long time. So a lot of people implemented that and did not deal with complexity of SIP outbound. There are some benefits of doing SIP outbound over UDP because you know when device is recovering, but in reality, they haven't been big enough for people to implement outbound over UDP. And IPv6 might change that. The second half of that problem is outbound with TCP or TLS. And once you start dealing with outbound over TLS, the requirements, the load on the registers grows tremendously. And that's been one of the issues why TLS has not been deployed, or connection-oriented protocols have not been deployed as much in the large-scale deployments, just because to scale it to the same size deployments as UDP will require a lot more resources on the service provider side. And the cost of extra registration grows exponentially comparing to UDP. So that's been keeping people from deploying outbound with TLS. And whichever solution we pick for the dual stack, it needs to work with connectionless like UDP protocols. I think that's the bigger problem than just essentially not forcing people to do outbound over TLS to solve happy eyeballs or to solve dual stack deployments. Is like forcing that would be a big problem. If they can still do it even with outbound over UDP, I think that's still acceptable. I think that's it. Thank you.
Thanks. Oleg?
Ole Johansson, I think you're assuming that all server-to-server connections are provider connections. That's not the case. I hear your case of providers, but there are other server-to-server connections where happy eyeballs come in. And we're not discussing outbound as a solution for happy eyeballs for connection-oriented protocols. So TLS is more or less solved, but a happy eyeballs RFC. The problem we have and need to focus energy on is UDP. And to respond to both you and Christer here, who had an off-mic question, is that with UDP, we can set up and select the flows and have time for timeouts and failures and all that mess at registration time, like an outbound, then keep the flow open with keep alives and use it for the incoming outbound calls. So for UDP, it's actually one-legged outbound flow is actually kind of a solution. And I think Christer mentioned something about NAT helping sessions, and we've seen what carrier-grad NATs do in dual stack mobile networks. They're not helping any sessions, they're destroying them.
Just to kind of answer that, first of all, not all SIP flows are registration-based. There are a significant number of deployments which essentially just an invite starts with the call from the client without the previous registration. So that needs to be addressed as well, and is not being addressed by outbound with UDP, where you can spend a significant amount of time on initial registration and figuring out the working flow before you can place an invite. The second issue is again, recovery, if you're running a single leg outbound, if that flow fails, essentially, in a lot of cases, because of the time required to find the working flow and re-register, your call in progress will fail as well, or the end customer will hang up. So there's a need for essentially some sort of a quick recovery mechanism with this one leg outbound, so that the signaling can be recovered quickly enough in case of either local IP address change or the edge proxy failure. So that's one of the reasons I think why this recovery came into this whole discussion. But that's, I think, is one of the requirements for the dual stack, is being able to recover signaling when the flow stops working.
So, Ole, we had Paul Kizovit in the queue. I want to go ahead and give him a turn, then we can come back real quick.
Hi again. We usually try, we try really hard to segment our problems to keep the problem space small, but it seems like there may be there may be some advantages to combining problems, in that there's a lot of focus here on UDP, because it's believed that the connection-oriented stuff is too expensive or something, but UDP really doesn't give us the privacy. And with all the emphasis on opportunistic, security, seems to me like we can anticipate there's going to be more demand for, securing, that link, to the endpoint, where, and we don't really have a good solution for that with UDP right now. So it seems like either we're likely to need, one way or another, to find a way to make TLS acceptable in this environment, or if that really isn't feasible, then maybe we need to be figuring out how to use SIP over DTLS, if in fact that would actually mitigate any of the problems with TLS.
Okay.
Ole Johansson again. I would be, in my quest for deprecating a lot of old stuff, I would be happy to deprecate UDP, but Roman wouldn't accept that, I guess. So, I mean, let's stay focused on happy eyeballs, trying to find the connection flow as quickly as possible. TLS, well, with happy eyeballs, we have a solution for all connection oriented. So I don't see any problem there, really. Where we need to focus again is UDP, and especially since, I mean, outbound, where you have to start with registering, Roman, if you read the documents, isn't accepted as a solution, then we need to find some other solution. And all possible solutions we've seen so far involves losing round trip times. Like in TCP, we need to send something funny, strange, and see who responds quickest, and then use that connection for the real request. If we can find another solution, I would be happy to look at it. But we've been discussing this for years in the SIP forum, IPv6 working group. We had many phone calls surrounding this, and we discussed it in this group. And so far, we haven't found any good solutions without losing round trip times. And I think outbound over UDP will solve many use cases with desktop phones that just stand there and do registrations in the background. For SIP clients and mobile phones, we have a whole other set of problems, and we probably need to discuss those issues where you actually want to set up the flow at call setup. But then we're back again to losing one round trip time.
Krista, just Ole, you can probably answer this. Just for clarification, what do you get with a one flow outbound that you don't get by just sending keep alives? What's the outbound parts that you need? Because in addition to the keep alives, what outbound have is these flow IDs, but those you're not going to need since you only have one flow. So what do you actually get from a one flow outbound that you don't get from just using keep alives?
Just using keep alives without the keep alive specified that actually send a response. Well, we can do that, but that's still, we need a response from a server saying, I understand SIP, I understand you, and we have a working connection, right? So we can, instead of registering like an outbound, we can come up with another solution, sending something that generates a response. So we know we have a working SIP server to speak with. That's the whole idea with Happy Eyeball, to find something that works, right?
Yeah, we have a lot of remote participants.
I mean, reply was that you will get a response to the register even if you don't use outbound. You send a register and you will get the response if it works. You don't need outbound for that, right?
Jonathan, next. My first point was that I heard people sort of vaguely mention the server-to-server case, but I'm still not sure what solution people have in mind, since clearly outbound won't work for that because you're not registering anything. And my second comment is this is probably, shouting into the wind, but how sad I am that forking won't solve this. This is clearly forking if forking worked. You just fork to V4 and V6. Done.
I'm putting myself in the queue behind Roman.
Oh, can you put me in the queue too?
Okay, so again, I just wanted to kind of say the same thing, that if working were working, or at least working in some, there was a way to, like if you design a register to register or a call processor to aggregate transactions received over multiple transports, that works quite nicely. The other thing I wanted to mention, which was related to a single connection outbound, what happens is even what you get from outbound when you're trying to set up the initial connection over UDP, you essentially trying to register over multiple flows. So you are like, even though you're going to maintain a single flow for outbound, initially you end up with multiple. And what you get from outbound are device ID, knowing that all those multiple registrations you got belong to the same device. So that's probably the main benefit of using outbound with Happy Eyeballs during the initial registration. That's it. Thank you.
Thanks. So Adam Roach, again, as if from the floor. And this is based on Jonathan's observation. I actually had meant to ask closer to the end of Dale's presentation, but Dale, are you actually on again?
I think I'm on. Can you
okay, I thought I heard your voice. So I had a question around specifically, you'd mentioned that you either thought that we could not use or were trying to avoid request merging as a solution to this. And it seems to me that since we've taken the pain of actually having that specified in the protocol, is it something that you just think is unaesthetic, or is there some reason that it actually won't work?
That's what I came up to the mic for. Can I take that one, Dale?
Sure, go ahead. I'll follow you.
The problem is that you might not get a merge, Robert Sparks. You might not get a merge. You might land on two different UAs, and you might get two 200s. You really want to take forking as a way to solve this off the table.
I concede the point.
Well, let me fill in here. I actually ran into a situation in practice that had this problem. We had a connection. It was actually a trunk between two switches, between two proxies, that was not particularly reliable. It was configured using SIP : whatever the host name was, by which I mean it would attempt both UDP and TCP. What happens is a call was being sent from one proxy to the other. It would send using one transport protocol. not get an answer, and then it would fork, send using the other protocol. It turns out the requests both got there, so they went to the second proxy. The first request went to the user agent question. The user agent starts ringing. The second request comes in. It gets sent to the user agent, which is busy, and so that forking immediately fails over to the voicemail system, which then sends 200, and the call gets put into voicemail.
Yeah, your audio goes up again.
Dale, I hate to say this again, but your audio has done the same thing as it did last time. Yeah, I believe we heard the answer. If you can still hear us, are you by any chance on a wireless connection? And if so, can you get closer to the access point? This does sound like what happens when people get too far from Wi-Fi access points on VoIP.
And we have many people in the room to assist you.
This is the right working group. Okay, Jonathan, go ahead and go ahead and let us know when things are going better for him, please. Ole
Johansson. Coming back to Chris's question, why can't you just send a register? RFC 3263 says that for every transaction, you need to do the DNS lookup. So your register may end up in another server using another protocol than the invite request. So we're not solving the problem with the call. And the problem with the call is the focus, because as Dale said in an earlier slide, waiting up to the default value of 32 seconds before maybe failing over is a usability problem. Most people would have hung up and called support on the mobile phone before that happens.
The note taker would like to know if there's any conclusion to this discussion. So our problem that
Andrew Allen, well, we do have a way to force invite requests to go to the server, and we use that in FreeGPP. We have the service route. We can force invites to go.
That's true.
Yep. That's one solution. So Ole Johansson again. The way I discussed this with Gonzalo at lunch was that let's first chop off the connection-oriented stuff and write a recommendation on how that fits in. And that's probably a 2 or 3 page document without much discussion. Then go ahead and look at outbound service route, or if we need something else, because as we see here, that discussion will take time. So let's pick these easy fruits and take UDP separately.
So that definitely sounds like a reasonable approach to me. If you want to break off a TCP document to progress that quickly so that people who are using TCP can get the problem solved for them.
Yeah, we want to get the documents out there for developers to work with so we can test at SIP it later that they did it right.
Any other thoughts on that? Sorry?
Dale says he's back and it's probably not a Wi-Fi problem.
Okay, all right. So Broman's on the queue now. And then we'll go ahead and have Dale pick the presentation up after that.
Again, just a note that this is not just TCP connection oriented, so TCP, TLS, all can be solved very easily. Just have a quick recommendation for people to how to implement that for anything connection oriented. And again, I agree, UDP is something which needs to be solved as a separate document.
I think what I heard you say is you're generally agreeing with the proposal, but you want to make certain we're covering things other than merely TCP.
Yes, exactly. Anything connection oriented should be basically covered by the document, because that should be trivial with happy eyeballs and with existing specifications. And connectionless is something which would require a separate document.
Right. Okay. Thank you. Okay, Dale, I'm handing it back to you now. If you're talking, we can't hear you. Jonathan? Okay. In the meanwhile, I did actually, I'm a little surprised that Robert didn't hop up at the mention of timer tweaking. And this seems like a good, I know that you're going to have something to say on the topic.
Back up to the slide. So I didn't hop up because the way that this slide was presented, I got the very strong impression that the point of the slide was don't do that. So there felt no real reason to hop up. But I will call out that reducing T1 is probably not a good idea. You can get rid of the word probably. And in fact, you can just say, no, you cannot do that. To reduce T1, it is an error to reduce T1 on one hop of a several hop network where things are actually running SIP, where you're not running a B2B UA, right? If you're terminating your SIP at a B2B UA and T1 is all one thing on one side and all something else on the other side, then it's your problem as a B2B UA to, figure out the discrepancies that you're going to get in the user experience, because there are going to be some and they're going to be very bad. If you're acting as a proxy, you're doomed. T1 has to be the same on the side coming in and the side going out, or stuff just breaks.
Right. So actually, it wasn't the T1 thing. I believe that everyone understands that that's the not good thing. The conversations so far, though, have actually discussed turning BNF down to a significantly smaller number of retransmissions. And it's, that has some pretty strong implications.
It's a proposal. It's going to require some analysis. Yes, there are really strong implications. It's working against themselves to trade off getting things working faster against not getting things to work when they might have otherwise in a semi-flaky network situation.
Right.
Right. So if the folks that are working this want to pursue it, they just need to write very carefully down what those trade-offs are and get an analysis of whether or not they're actually going to be worth it.
Okay. Yeah, what I wanted from you was if we had different notions of timer B and F in a network, whether there were bad interactions that you were aware of that we needed to make certain were part of that analysis, since you have a lot of the non-obvious timer interaction problems in your head.
F is going to be pretty, the analysis for F is going to be pretty easy to do. The analysis for B is less obvious. And I would have to go think about what would happen when you start messing with B a little bit more thoroughly. I think you might run into similar problems with false detections of failure to connect on invite when timer B is not the same on both sides of a proxy. F isn't really going to matter because that's going to be bound by T1, right? But because proxies can pend, B matters. So I'd have to go study it, but need to look very closely at what happens when B is not the same side on those two hops.
Okay, can I lean on you to send an email to the list after doing some thinking on that? Thanks.
Ole Johansson. I think for me, this slide is out of scope for happy eyeballs. This is the problem. If you do it serially, test one server first, then you're going to run into this timeout. And what we want to avoid is exactly using timers. We want to set up the sessions in parallel. And then you can use timers as you always do, right?
Well,
that gets back to what my original takeaway was. I thought what I was hearing was that this whole slide was a don't do this.
Ah, okay. It is that.
And this is exactly how we discovered the problem at SIPCORE tests.
Okay, thanks. That's not what I got from the conversation on the list, but I may have misunderstood. Alan?
Andrew Allen. So just to add to Robert's point, so as I understand it, there's no way for the UA to know whether there are back-to-back UAs or proxies in the path. So for a generic solution, there's no way that you can reduce T1.
Right. Okay. I don't even see Dale on the list right now. Oh, okay. Well, let's see. We had only 3 more slides. I presume that you were working with him on this, Ole. Do you think you can take us through the last of this?
Some of the slides I've been working with him on, some is based on his draft. But he covered the recovery, right? Which I think is a whole different issue than happy eyeballs.
Right.
Yeah, I think so. Yeah. So he came up with an idea of work plan, and I think in our discussions we said, well, let's even more quickly focus on getting rid of the connection-oriented protocols, so we can focus here. I don't know. I was suddenly thinking WebSockets, but that's ugly. But some of this, like Outbound Light, or half Outbound, whatever you call it, was something I started discussing for a whole different set of problems, which is TLS. But then we discovered that, well, it may be one of the solutions for UDP as well. So I think we need to define the problems for UDP in a separate document. As you hear, I don't agree with Dale on all the details. That makes life fun. Keep alive and low overhead NAT. I don't really know what he means there. Next slide.
Okay.
You have to help me here, Gonzalo. And DTLS Lite is obviously out of scope for happy eyeballs, but I got a question from Dale earlier on about that, and I think that's an interesting path to go down in this working group and see if we can do anything that can irritate and help us traverse algs is interesting. And I hear from Roman that people still don't like TCP and TLS, so maybe DTLS is a way to something we need to explore, but again, not related to happy eyeballs. I want to keep happy eyeballs in scope. And the call transaction recovery, well, that's something I see constantly now in various networks. Also out of scope for happy eyeballs, but a very interesting completion of the Outbound project, I would say.
So I generally agree with what you said there. I think especially the two things in this slide is something we might want to defer until we have some concrete proposals on the table, but not part of the happy eyeballs work, right?
No.
There might be some interesting work in this space. And as I'm looking through this, all of these are actually stated in terms of solutions that I think maybe a bit more concrete than we want to think about at the moment. It's, I would be very happy to see us putting something in front of the ISG for connection oriented at the beginning of next year, and then continue to work on UDP and other.
I think a document that describes the problem with UDP and the possible solutions that we currently have in our tool set, like service route and Outbound, and finds the gap, and then we can focus on the gap for a while. It'll be a very interesting discussion that needs some innovation and a lot of good cups of tea.
So almost a requirements document that does a survey of potential solutions then?
Yeah.
That sounds
fairly easy to come up with as well.
Okay. And that's something that you and Dale, you think you could work on together?
Yeah.
All right.
And Gonzalo and the rest of the crew. I mean, we still have the working group in the SIP forum, so we can go back and get some inspiration from those guys and wake them up.
All right. Cool. That sounds good. So I'll sit down with Ben and see if this is something we want to take on as a couple of milestones then. Because it sounds like there's at least enough knowledge and energy to probably push those things forward. I think I would like to defer the conversations around the additional ancillary topics having to do with DTLS and having to do with connection recovery until either those are further along or we have a larger group of people. Because I don't want like the four of you working on 4 documents in parallel, because that's never going to make progress.
I can add to this that when we found this was a lab discovery at SIPIT where we create evil networks. But during the last couple of months, actually, I have 2 different customers and a third one, not customer, but a third developer company that actually called me, and we have discovered these dual stack issues in real life networks with real life users. So it's actually, we're in quite a hurry to get some documents that I can feed back to the developer saying, now do this.
By any chance, can you share whether those developers were connection oriented or TLS or UDP?
UDP and connection oriented.
Okay, so a little bit of both then. Yeah. Okay, thanks, Jonathan.
Yeah, Jonathan Lennox. I mean, I think the reason why DTLS is coming up here is because DTLS is, despite being connectionless, it's for these purposes connection oriented, which is so you can happy eyeballs it by doing the handshake. So I mean, and so I mean, you can do zero RTT with DTLS 1.3, but you don't have to. So I think so that gives the architectural benefits of the connectionless that people like, while still having a pre-handshake that you can do experimentally as needed. And I think that's why DTLS is coming up here.
So I suspect Roman's actually going to say the same thing that I'm about to ask. But do you think that the architectural considerations you're referring to are actually? I mean, my understanding is that it's a drive to simplicity, not necessarily wanting to have things in datagrams per se.
I mean, I thought it was also. I mean, it was also a drive to capacity, I thought.
Connections. Right.
Yeah. So
well, but
yeah,
then
DTLS,
associations is also a problem.
Well, no, because I think associations can keep all their state client side. I think. I don't know TLS well enough to be sure, but I think so.
That would surprise me.
Maybe not.
I don't see anyone in the room who can answer that.
Yeah.
Okay, Roman.
That's exactly what I want to answer. As far as scalability is concerned, DTLS is only slightly better than TLS, because essentially, primarily because of the counters, which need to be maintained for each message which is being sent, both on the client and the server side. So you end up with fairly frequently updated state. It's and if there is any way to kind of move those counters to like either SIP sequence numbers or anything like that, so it will require some sort of DTLS modification. But if we can move this some of the state into the actual SIP message, then this will work. But until this, it will require the constant state maintenance in both server and the client. That will essentially have the same characteristics as TLS for the scalability.
Roman, can I get you to document on the mailing list what those specific concerns are? I'd like to have something that I can concretely forward to some DTLS experts.
Okay, I will do that, but that's primarily sequence number maintenance. I will write something on the list.
Okay.
And Dale says in the room, he says announced each of the items listed on the work plan he listed would be a separate RFC. So he wanted to make sure that was clear.
That was my reading of this as well. So are there any other aspects of this problem space that we think talking about would be useful here? We'll let you look expectant. No? Okay. All right. Well, I think we probably have enough energy here to definitely move forward with this work. I'd love to see more discussion on the mailing list. I mean, it's great we have a document together, but just there's clearly thought around ways to address this. So more messages. And I think that's probably it. Thank you, everyone, for showing up. Any other business people would like to discuss? All right, great. Well, thanks. Enjoy the plenary. Thank you, Roman. And thank you very much, Dale.